My name is Joshua Tambanan, and this is my smart coffee cup detector. I like to call her Big Betty, 1.5 meters by about 0.6 of a meter by 0.9 of a meter tall. And the main purpose of Big Betty is to be able to detect coffee cups, as shown in the table, such that it can sort the coffee cups into its separate type. So what most people don't know is, if I grab one of these cups, that although it looks paper and it says paper on the outside, right, single wall paper hot cup, the inner lining is polyethylene, which means that it can't actually go into anything but waste or a special treatment plant. And most bins in Australia don't have pre-allocated polyethylene cup extraction lining bin. It's just not common. So the misconception lies in having a lid like one of these. So this lid here, it says PS6, which is polystyrene, and most people see that logo, that little triangle, and think, oh, well, it's recyclable. But if you throw away the lid with the cup together and you put it into recycling, you're actually contaminating all the recycling with this cup. So what you should be doing is separating the cup from the lid and then throwing the cup in the waste and the lid into recycling. Now recently at the university, they're introducing new kinds of coffee cups. So this is made by Biopack. So they said made from plants, not oil, because the inside is actually made from PLA, or polylactic acid. And that's the byproduct, the secondary product of corn and other agricultural produce. So it's compostable, which means if treated correctly, you can actually use it for other purposes other than landfill. So that's why we have 3 bins. Let's come back to Big Betty. So Big Betty has the red bin, which is waste, the yellow bin, which is recycling, and the blue bin, which is compostable. I couldn't find green, so yep. And although Big Betty isn't at her final form, as you can see by the prototypey looking blue tag, you can only throw your waste inside here, this hole in the acrylic. And the assumption is that whoever the user is, they think, oh, I put my coffee cups in recycling, which is where the assumption is. And now there's supposed to be flaps, at the very bottom of Big Betty, here, but they're not attached at the moment. And you can see that there's slots cut out for, if you can see the slots cut out for the servos being these, where they're supposed to sit and control the flaps, which are these at the bottom, once secured. Now, there's another servomotor here, this dark one, and that's supposed to control the funnel. So after detection, after looking at whatever the object inside of it is, we can see if it's a normal coffee cup, so it's going to go here, and we rotate it that way. If it's recycling, so we just drop, or if it's going to compostable because it's a compostable special cup. But let's try to walk through the scenarios. So we're simulating the scenarios at the moment, and if you can see that, we're just saying that we pretend that we've identified it, and it either goes into waste, recycling, or composting. And the way we do that is we trigger with what should be a button, but we'll do a switch. Now, it should start, and it thinks it's recycling, so it only responds to by dropping and opening the flaps. I'm going to simulate one more time and call it out so that you can see what's happening in action. And these are randomized, so bear with me. See? Okay, and the detection is waste, which is why Big Betty's rotated that way, release the flaps, and then centered back. And let's see if we can trigger compostable. With any luck. That was recycling. One more time. That's compostable. And she opens the flaps, and Bob's your uncle. So, Now you're thinking, okay, so that works. We simulate it, provided that the cup actually falls into the bins. But how do we detect it? So at the moment, it's not entirely connected yet, but we get a test cup onto this pie set up here. And the reason why there's a black box behind it is to have a clear backdrop for the photo, which is here. And what we're doing is we're using a Google Vision API to use machine learning and Google Vision API to take the photo, send it to their servers, figure out what the object is, and come back with labels. If the screen comes back red, then we know that it has failed to detect a coffee cup. Oh, yep, need to press enter. Still talking to the servers. Yep, so it's green, and we can see the values if we scroll up. The values that we actually got was cup, drinkware, drink, cup, and tableware. Now, what I've observed from testing all these various types of cups is if you have a coffee cup that has, especially the word coffee on it, it triggers it quite well. So keywords, it can register text, so keywords are very important. If it has a lid, it's quite good. If it's on a certain angle, so a certain position, like for example, if it's straight on like this, it might be confused. But if it's just ever so slightly angled, or at a setting where it could be like a cafe on top of that, that helps with the algorithm. And here's the next bit, which is interesting because we can detect a coffee cup, but we don't have an idea on the material yet. So I'll show you what is done with the material. Just quit through that and go IR demo. Python. Oh yeah, so this is all written in Python, and in a while I'm sure I'll make it public repo for any of those developers out there. And so what it's doing is it's using the near infrared spectrometer that's located there, send an IR beam here, read all the values that comes back, because what IR is it's just light, and it comes back slightly diminished than what you've sent, as with most things in life. And what you get is a profile of what the material is, because that's how that's what controls the reflection index. And so these are the values, right? There's 6 different channels in the near infrared band, I guess, is what you call it. And using a generalized linear model, after collating a lot of the data from sampling these cups, I have a binary model for whether it's a compostable coffee cup or not. So it just tells you, hey, it's a compostable coffee cup, I'll go green. It's not a compostable, I'll go red. So with this particular example, that's a recyclable lid, which isn't too interesting. So if we take off the lid and we take, this is another recyclable cup, and you know because it has the Biopack art series. But we can also take one that's from UQ in one of the vendors, which is Merlot's, and it has the biodegradable compostable symbol, including the extra bit of text to tell you that it is certified compostable there. Okay, if we take this, if I can lift it without ruining the setup. Yep. And if I do the scan, just to show, if I do the scan, it doesn't break, hopefully. Ooh, no bueno. That is no bueno. Let's try another one. So with the generalized linear model, it did have an acceptance area under the curve, acceptance rate, of 0.833, which means it's quite accurate in that it won't give you too many false negatives. It will try to give you as many false let's go with the artwork one, just to show that this works, hopefully, and that the sunlight didn't actually change all my values of my linear model. Last one. Yikes. Oh, well, looks like there's an extra bit of problem. Yeah. So if you like what you saw, if you have any suggestions for what I'm gonna do, what I should do to improve Big Betty, please let me know. This is Big Betty. Thanks for watching. Ciao.